Right now, Earth is spinning faster than it has in decades. Then, this year, it started slowing down again. A hole in our planet's shield is stretching wider every year. A giant ocean current that keeps a whole continent from freezing is losing power. Space rocks are hitting us from angles that should not exist. Something is shifting deep in the ground, deep in the ocean, deep in the sky. If you enjoy uncovering what is really happening to our planet, hit like and subscribe before we go further. Every fact ahead is real, checked, and stranger than fiction. Get ready. Earth is changing right in front of us. Somewhere above your head right now, Earth is spinning slightly differently than it used to. Not in a way you can feel, not in a way that shows up on any clock in your house or on your phone. But scientists with atomic clocks, the most accurate timekeeping tools ever built, have caught it. Starting around 2020, our planet began completing full rotations faster than normal. A day is supposed to last exactly 24 hours, or 86,400 seconds. No more, no less. For years, Earth kept finishing early, just a tiny bit early, a few thousandths of a second, over and over. That sounds like nothing, less time than it takes you to blink one single time. But when scientists tracked it year after year, they realized something strange was going on. 2020 gave us some of the shortest days ever recorded. Then 2022 beat that record. Then 2024 beat it again. Every single time, scientists expected the trend to stop and Earth to settle back into its usual rhythm. It didn't. This is confirmed, measured fact, not a theory, not a guess. Real atomic clocks, checked constantly against Earth's actual spin, over and over, year after year. Here's the part that makes it even stranger. In 2026, the pattern flipped completely. After years of speeding up, Earth started slowing back down. Nobody predicted the flip would happen this fast, and some scientists are still catching up to what the new numbers mean. Picture a spinning top on a table, the kind you might have played with as a little kid. Most of the time it slows down smoothly, gradually, the way you'd expect any spinning object to run out of energy. This top sped up for years instead, then suddenly reversed direction of change, like an invisible hand reached down and nudged it without warning. That is basically what happened to our entire planet, and researchers are still working out exactly why it happened the way it did. A geophysicist named Duncan Agnew compared watching Earth's rotation to watching the stock market. There are long-term trends, he said, and then there are peaks and falls that don't always make sense in the moment they're happening. Something inside our planet, or maybe something happening in its oceans and atmosphere, is nudging the spin around in ways that break the pattern scientists thought they had finally figured out. And this isn't just a fun fact for astronomers sitting in observatories. Every rotation of Earth is the invisible clock that satellites, the global positioning system behind your phone's maps, and the entire internet all quietly depend on to stay perfectly synced. When that clock gets even a little unpredictable, things downstream can wobble too, in ways most people never notice until something breaks. We'll get to exactly how in a minute. But first, you need to understand what's actually causing the spin to change at all, because the answer involves something much bigger than the planet simply speeding up for no reason. It involves ice, oceans, and a shape-shift happening to Earth itself that most people have never even heard of. Scientists have a name for it, borrowed from an image you've probably seen in real life 100 times without ever realizing it connects to any of this. Stick with this part, because once you see the picture, you won't be able to unsee it every single time you watch the Olympics again. Have you ever watched an ice skater spin during a routine at the Olympics? They start with their arms stretched wide, turning slowly. Then they pull their arms in tight against their body, and suddenly they're spinning so fast their whole body blurs into a streak on the ice. That single move is physics in action, plain and simple. And it turns out Earth follows the exact same rule, just on a scale so massive it took scientists decades to fully measure it. When mass moves closer to the center of a spinning object, that object speeds up. When mass moves farther away from the center, it slows down. No exceptions. Earth spins on an axis running straight through the North and South poles. For most of history, huge amounts of frozen water sat piled up at both poles, far from Earth's center, like a skater standing with her arms stretched all the way out. But our planet is warming, and that ice is melting fast. Water that used to sit locked in polar ice caps is now flowing into oceans near the equator, which sits farther from Earth's spinning axis than the poles do. That shift moves mass outward, away from the center, exactly like a skater slowly extending her arms back out mid-spin. And just like the skater, when mass moves outward like that, the spin slows down. A team of researchers from ETH Zurich and the University of Vienna studied this in detail, and what they found genuinely stunned them. Right now, the length of Earth's day is increasing at a rate of about 1.33 milliseconds per century because of this exact process. To find anything close to this fast happening in Earth's history, scientists had to dig back 3.6 million years, using fossilized ocean creatures buried in ancient seafloor mud to rebuild what day length looked like that far in the past. Only once in all that time, around 2 million years ago, did the rate of change come close to matching what's happening today. Never before or after that single moment has this shift happened as quickly as it's happening right now in your lifetime. This is confirmed by actual published research, not speculation dressed up to sound scary. So if melting ice is slowing Earth down over the long run, why did the planet spend years speeding up instead, setting record after record for the shortest days ever measured by anyone? Here's the twist that makes geophysicists lose sleep over their own spreadsheets. Two completely different forces are pulling on Earth's spin at the same time, in opposite directions. The slow, steady melting of ice is one of them, stretching the skater's arms back out bit by bit, year after year, decade after decade. But something else, something happening deep inside the solid rock and molten metal of our planet's core, has been yanking the spin the other way entirely, hard enough to overpower the ice effect for years at a stretch. Scientists don't fully understand what that inner force is doing, or why it seems to be shifting gears now, right as we watch and measure it in real time. And when two enormous, opposite forces are both acting on the same spinning planet at once, the result is never calm. It's unpredictable. It's the exact kind of unpredictable that made timekeepers around the world start seriously preparing for something that has never happened once in the entire history of human civilization. Here's something almost nobody outside of a science lab has heard about, and it's unfolding this exact year. Since 1972, whenever Earth's spin drifted out of sync with atomic clocks, scientists added something called a leap second, an extra second tacked onto a specific day to nudge our clocks back into alignment with the actual planet. It's happened about once every year and a half on average, and you've probably lived through dozens without ever noticing a single one. But every single leap second in history has been added, never subtracted. Until now, that's all anyone needed to plan for, and every engineer on Earth built their systems around that one simple assumption. Then Earth started spinning unusually fast, and for the first time ever, scientists began seriously preparing for the opposite, a negative leap second, where instead of adding a second to the clock, they would have to remove one entirely. That has never been done, not once, in the entire history of modern timekeeping. And removing a second turns out to be a much bigger problem than adding one ever was. When you add a second, computer systems just get an extra 60 first tick inside 1 minute, which is unusual but manageable, something programmers already know how to handle. When you remove one instead, a minute has to skip straight from 58 seconds to 0, erasing a number that software everywhere silently assumes will always exist somewhere in the count. Engineers who build banking systems, air traffic networks, and satellite navigation have openly said that a negative leap second is the kind of event with, in their own words, no software patch history behind it. Nobody has ever fixed this bug before, because the bug has literally never happened before, anywhere, to anyone. Timekeeping officials are watching Earth's rotation so closely that in October of 2026, representatives from countries around the world are meeting to vote on whether to replace the leap second system entirely with something much bigger, a leap hour, added only once every century or so, instead of constantly fiddling with individual seconds. The reason behind the urgency is simple. Some experts estimate close to a 1 in 3 chance that a negative leap second could actually be required sometime before 2035, and officials would rather solve the problem calmly now than scramble to fix it later when Earth forces their hand without warning. Here's why any of this actually matters to you personally. The satellites guiding your phone's maps also help pilots land airplanes safely and timestamp financial transactions down to tiny fractions of a second. All of that depends on every clock, everywhere on the planet, agreeing on exactly what time it is, all the way down to milliseconds nobody can see. When Earth's spin becomes this unpredictable, speeding up for years and then reversing course faster than anyone expected it to, the invisible clock underneath all of modern technology starts to wobble in ways engineers are only now learning to handle. And this rotation puzzle, as strange as it already sounds, is just the surface of what's changing. Because while scientists were busy measuring Earth's spin down to the millisecond, satellites orbiting far above the surface picked up on something else entirely, something happening to the invisible shield wrapped around the whole planet instead of to how fast it turns. And that shield is starting to fail in one specific spot, a spot that's been growing steadily for over a decade now, with no sign of slowing down. Deep beneath your feet, about 1,800 miles down, at the boundary where Earth's molten outer core meets solid rock, something is generating one of the most important forces protecting life on this entire planet. That force is Earth's magnetic field, and most people never think about it, not even once in their whole lives, because you can't see it, taste it, or touch it. But it's there every second of every day, acting like an invisible force field wrapped completely around the planet, working quietly whether you notice it or not. Here's what it actually does. The sun constantly blasts charged particles out into space, a stream scientists call the solar wind. Without something stopping those particles, they would slam directly into Earth's atmosphere, stripping it away over time the same way scientists believe it happened to Mars billions of years ago, turning a once wetter, warmer planet into the dry red desert we see today. Earth's magnetic field is the reason that hasn't happened to us. It deflects most of that radiation around the planet, like an invisible shield curving through space. But south of South America, stretching out over the Atlantic Ocean, there's a patch where that shield has always been noticeably weaker than everywhere else on the globe. Scientists call it the South Atlantic Anomaly, and it was first noticed by researchers back in the 1800s, using some of the earliest magnetic surveys ever conducted. For a long time after that, it stayed roughly the same size, barely worth a second glance. Then, starting around 2014, satellites began tracking it constantly, around the clock, and the readings started changing in ways nobody had seen before. The National Aeronautics and Space Administration describes this weak spot almost like a pothole in space, a dent in the invisible shield surrounding Earth. Inside that dent, more radiation than normal is able to dip closer to the surface than anywhere else on the entire planet. It doesn't affect you walking around outside on a normal day. Your body is completely fine down here, but it absolutely affects anything flying through that region high above the atmosphere. Satellites passing through the anomaly get hit with significantly higher doses of radiation, and that radiation can scramble onboard computers, damage sensitive equipment, and in some cases knock out a satellite's systems entirely, causing what engineers simply call a blackout. This isn't some rare, one-time glitch, either. It happens often enough that space agencies plan satellite operations around this region specifically, sometimes powering down non-essential systems before a spacecraft passes through it, the same way you might close your laptop screen before walking through airport security just to be safe. And this weak spot in Earth's protection isn't just sitting there anymore, staying put the way it used to. Recent satellite data confirms it clearly. It's expanding, growing wider every single year that scientists go back and check on it again. The question that used to only interest space agencies is starting to matter to everyone listening to this, because a shield that's actively weakening in a spot that keeps growing wider raises one obvious next question. How much bigger can this hole actually get before it starts to matter for more than just a few passing satellites? The answer scientists found next was even more unsettling than the question itself. In science, claims need proof, and this one has plenty of it, backed by real satellites and real numbers. The European Space Agency operates 3 identical satellites flying in tight formation around Earth, together called the SWARM mission, built specifically to measure our planet's magnetic field with extreme precision down to details no ground-based instrument could ever catch. For 11 straight years, from 2014 to 2025, SWARM collected constant data on the South Atlantic Anomaly, orbit after orbit, without a single break. Researchers finally compiled all of it into one detailed study. The result was published in a peer-reviewed science journal, checked by other experts before anyone was allowed to publish it. And the number inside it was jaw-dropping. The weak zone in Earth's magnetic shield had expanded by an area nearly half the size of the entire continent of Europe. Picture that for a second. Not half the size of a country, half the size of an entire continent, one that includes dozens of nations and hundreds of millions of people, all fitting comfortably inside. The size of new territory this magnetic weak spot has swallowed up in just over a decade. And the growth wasn't even the strangest part of the discovery. The lead scientist on the study, a professor of geomagnetism named Chris Finlay, discovered the anomaly wasn't behaving like one single, uniform blob slowly spreading outward in every direction equally, the way you might expect a puddle to spread on a flat floor. It was doing something far more complicated than that. Near South America, the weakening was happening one specific way. But over near Africa, on the opposite side of the anomaly, the shield was fading even faster, and in a noticeably different pattern entirely. In Finlay's own words, there's something special happening in that region specifically, something causing the field to weaken more intensely there than anywhere else nearby. Picture 2 people slowly letting the air out of the exact same balloon, but from 2 completely different spots, at 2 completely different speeds, and the balloon stretching unevenly because of it, bulging strangely in one direction more than the other. That's roughly the shape of what satellites are watching happen to Earth's magnetic shield right now, in real time, orbit after orbit. This isn't guesswork or a computer model predicting some distant future. This is direct, measured, confirmed satellite data, collected constantly for over a decade by some of the most precise instruments humans have ever built and launched into space. And once scientists confirmed the anomaly was both growing and behaving unevenly at the same time, they had to ask a much bigger question. If the weakening happening in this one region is already this complicated, what's actually causing it deep down, at the source, rather than just on the surface where satellites can see it? The answer meant looking somewhere no satellite could ever directly see with its instruments, no matter how advanced that instrument was. It meant looking straight down, thousands of miles beneath the surface, past solid rock, and into a place where liquid metal that's hotter than lava has been swirling non-stop for billions of years, doing something that researchers are only now beginning to truly understand, one satellite pass at a time. To understand what's really driving the growing weak spot in Earth's shield, you have to go somewhere no human has ever been and no camera could ever possibly survive, no matter how well built. Roughly 1,800 miles beneath the surface sits Earth's outer core, an ocean of liquid iron so hot it would vaporize almost anything instantly, constantly swirling and churning because of heat rising up from the even hotter solid core buried at the very center of the planet. This swirling liquid metal acts almost exactly like the spinning conductor inside a bicycle dynamo, the small device attached to a bike wheel that lights up a headlamp just from the wheel spinning around. As the liquid iron moves and churns, it generates electrical currents, and those currents generate Earth's entire magnetic field. It's been running this way, non-stop, without a single pause, for billions of years before you were ever born. Normally, in the southern hemisphere, scientists expect magnetic field lines to behave in a certain predictable way, flowing outward from the core toward the surface, like water rising up steadily from an underground spring. But underneath the South Atlantic Anomaly specifically, satellites detected something backward, something that broke the pattern entirely. Instead of coming out of the core the normal way, in certain spots the magnetic field lines are actually curving back down, returning into the core instead of rising out of it towards space. Scientists call these unusual spots reverse flux patches, and their existence is confirmed by direct satellite measurement, not theory or guesswork dressed up to sound impressive. Picture a river that's supposed to flow one direction, downstream toward the ocean, the way every river you've ever seen always flows. Now picture a strange patch in the middle of that same river where the water is somehow swirling backward instead, flowing upstream, breaking the pattern that everywhere else around it still follows perfectly. That's roughly what these reverse flux patches look like happening inside Earth's magnetic field, right in the exact region where the shield is weakening the fastest. Scientists studying swarm satellite data noticed one of these backward patches, actively drifting westward over Africa specifically, slowly shifting position year after year, and they believe its movement is directly connected to why the anomaly keeps weakening harder in that particular direction. This is genuinely cutting-edge science, the kind researchers are still figuring out in real time, one dataset at a time. Researchers can see the effect clearly. They can measure it precisely from orbit using instruments built for exactly this purpose. But the deeper question, exactly what's stirring up the liquid iron core to create these backward patches in the first place, remains a real mystery, even to the experts studying it closely every single day of their careers. And once you understand that the weakening shield above us is being driven by something unpredictable happening in liquid metal, thousands of miles below the surface, the natural next question becomes impossible to ignore. If one side of this anomaly is behaving strangely, what's happening to the rest of the planet's magnetic field while everyone's attention stays locked on the Atlantic? The answer turned out to involve two opposite ends of the entire globe, doing two completely opposite things at exactly the same time. If Earth's magnetic field were simply fading everywhere at once, evenly, like a phone battery slowly draining down to zero over a long day, that would almost be easier to understand and explain. But that is not what satellites are recording, and the actual pattern turns out to be far stranger than that. While the South Atlantic Anomaly keeps expanding and weakening, researchers tracking the global magnetic field notice something happening on completely opposite sides of the northern hemisphere at the exact same time. Over Canada, a region where the magnetic field has traditionally been unusually strong has been shrinking steadily, quietly losing ground year after year without much public notice. But over Siberia, thousands of miles away on the other side of the entire globe, a separate region of strong magnetic field has actually been growing larger during that exact same stretch of time. Picture a seesaw on a school playground. Except instead of two kids going up and down, it's two entire continents worth of magnetic strength, rising on one end while falling on the other, and the fulcrum holding the whole thing balanced in the middle sits buried deep inside Earth's molten core, completely out of sight. Scientists have directly measured this happening using the same 11 years of swarm satellite data used to track the South Atlantic Anomaly. So this isn't speculation, it's confirmed observation backed by real numbers. The lead researcher on the study, Chris Finlay, admitted plainly that these specific changes in the northern hemisphere genuinely caught his team by surprise. He connected it to circulation patterns in the liquid metal core, the same swirling iron ocean responsible for generating the field in the first place. But he was careful to say scientists are not fully certain of the exact cause behind it yet. That kind of honesty matters here, and it's worth noticing. This is confirmed data paired with an honest scientific mystery, not a wild guess dressed up to sound like settled fact. What makes this genuinely fascinating, rather than purely alarming, is that Earth's magnetic field has actually done all of this before, many times throughout its billions of years of history. Scientists studying ancient rock samples, cooled and hardened millions of years ago, have found clear evidence that regions of weak magnetic field, similar to today's South Atlantic Anomaly, have popped up in the past and later disappeared again, without the field ever fully reversing. So this pattern of weakening in one place while strengthening in another might genuinely be part of a completely normal cycle that plays out over decades or even centuries. Essentially, the planet's own version of shifting its weight from one foot to the other while standing still. But normal doesn't mean fully understood, not even close. And it definitely doesn't mean scientists can predict exactly what happens next, or how far this current shift will go before it finally settles back down again. With one side of the planet's shield weakening, the other side strengthening, and the true cause still buried thousands of miles underground, where no satellite can ever directly see it, no matter how long it orbits, there was one question left hanging over the entire research team. The exact question everyone watching this unfold has been waiting patiently for an honest scientific answer to. Whenever people hear that Earth's magnetic field has a growing weak spot, expanding by half the size of Europe, with strange backward-flowing patches deep inside the core, there's one question that jumps to mind almost immediately. Every single time someone hears the story, is the magnetic field about to flip completely, north swapping with south for good, a full magnetic reversal, where north and south swap places entirely, is a real thing that has happened many times throughout Earth's long, layered history, confirmed by studying magnetic patterns frozen forever into ancient volcanic rock the moment it originally cooled. So, it's a genuinely fair question to ask, and the scientists studying this exact data gave a clear, direct answer to it. The study did not find any sign of an impending magnetic field reversal. That sentence is worth repeating slowly, because it truly matters here. Earth's field is fluctuating, not counting down toward a flip. Chris Finlay, the lead researcher, explained it using Earth's own deep history as solid evidence. Paleomagnetic records, ancient magnetic signatures, preserved inside rock formed over millions of years, show that Earth's field has weakened many times before, producing weak regions just like today's South Atlantic Anomaly, without those weak spots ever leading to a full reversal afterward, not even once. In Finlay's own careful assessment, what's most likely happening right now is a fluctuation playing out over a decade to century timescale, essentially a wobble, not a flip, the kind of shift Earth has absorbed and recovered from many times before. So if this is a manageable fluctuation rather than the doomsday scenario everyone secretly worries about, why does any of this still matter at all? Because confirmed and not dangerous are two completely different things from confirmed and fully understood, and it's worth holding both at once. The weakening itself is real, the growth is real, the uneven pattern stretching across the globe is real. What remains genuinely unknown is how far this specific fluctuation will go before it eventually reverses course, how long it will last once it starts settling, and exactly what's stirring inside the liquid iron core to cause it in the first place. Real science often sounds exactly like this, less like a dramatic movie trailer promising disaster and more like a team of careful researchers calmly saying, here's exactly what we've measured, here's what we can confidently rule out, and here's the honest boundary of what we still genuinely don't know yet. That honesty is exactly what makes the story trustworthy, not a weakness in it. And it's not scientists dodging the question either. Earth's magnetic shield is shifting in ways nobody predicted even a decade ago, and satellites will keep watching closely, month after month, to see exactly where it goes next. But the magnetic field is only one system inside a much larger, more complicated planet. And it turns out it isn't the only invisible, life-sustaining system currently showing clear, measurable signs of slowing down. Far above the South Atlantic Anomaly, at the ocean's surface, instead of deep in its magnetic core, another massive, planet-spanning system has been under close watch by scientists for an entirely different reason. And what they found there might affect your daily life even more directly than a wobbling magnetic field buried deep underground ever could. Picture a river, but instead of flowing between two grassy banks, it flows through the middle of an entire ocean, carrying more water than every single river on Earth combined, all moving together in one steady, continuous loop. That's essentially what the Atlantic Meridional Overturning Circulation is, a system so important to global climate that scientists usually just call it by its initials, the AMOC. But we're going to skip the abbreviation entirely and just call it the Atlantic Conveyor, because that's exactly what it acts like, day and night, every day of the year. Here's the simple version of how the whole system actually works. Warm water near the surface of the ocean flows northward from the tropics, up past the eastern coast of the United States, and all the way toward Europe and the Arctic Circle. Along the way, that warm water releases heat into the air above it, which is a huge part of why places like the United Kingdom and Northern Europe stay relatively mild instead of freezing solid, even though they sit at roughly the same latitude as parts of Canada that get brutally cold winters every single year. Once that warm water finally reaches the far north and loses its heat to the atmosphere, it also becomes saltier and denser through a completely natural process, which makes it heavy enough to sink deep beneath the surface, straight down toward the ocean floor. That cold, dense water then flows back south along the bottom of the ocean, completing a massive loop, like a conveyor belt running continuously between the tropics and the Arctic without ever stopping to rest. This entire system does double duty. It moves warmth from the equator toward the poles, keeping the whole northern half of the planet's climate stable and predictable, and it also carries essential nutrients through the ocean, feeding marine life along the entire route it travels. It has been running in roughly this pattern for thousands of years, quietly shaping the weather patterns that entire nations built their agriculture, their cities, and their whole way of life around without ever fully realizing it. Most people have never even heard of it, yet it's arguably one of the most important physical systems on the entire planet, working silently underneath the waves every single day of the year while you go about your normal routine above them. And for decades, most people, including plenty of scientists, generally assumed it would just keep running steadily forever. The same reliable conveyor belt it had always been since long before recorded history began. That assumption started cracking the moment researchers began actually measuring the conveyor directly, instead of just assuming it based on old computer models built on old data. What they found sent a real wave of concern through the entire climate science community, because a system this massive, this important, and this deeply connected to weather patterns across two entire continents had started showing clear, measurable signs that it was genuinely losing power. And unlike the magnetic field weakening deep underground, this particular slowdown comes with consequences that scientists can actually describe in vivid, specific detail, because they've already studied exactly what happens when this same conveyor belt has slowed down before, thousands of years back in Earth's own distant past. Claims about something as massive as an ocean current slowing down need real proof, not guesswork, and this time, scientists actually have exactly that kind of proof. A research team from the University of Miami's Rosenstiel School set up something remarkable: 4 separate monitoring stations positioned along the western edge of the North Atlantic Ocean, each one continuously measuring water temperature, saltiness, and the actual speed of the current flowing past it, minute by minute. And they didn't just check once and walk away, satisfied with a single reading. They kept these stations running and recording data for 20 straight years, starting back in 2004, through hurricanes, through changing seasons, through decades of ordinary life, happening on land above them. 20 years of direct, continuous measurement is about as solid as ocean science gets. Full stop. This isn't a computer model predicting what might happen sometime in the future. This is real sensors, sitting in the actual ocean, watching the actual current for 2 full decades without a break. When the researchers finally compiled and analyzed all of that data, the pattern staring back at them was unmistakable. The Atlantic conveyor had been weakening consistently at all 4 separate measurement locations along completely different latitudes, hundreds of miles apart from each other. Shane Ellipott, a physical oceanographer who worked on the study, pointed out exactly why that specific detail mattered so much. Weakening showing up at one single location might just be a coincidence, some local quirk affecting that one particular spot alone, but weakening showing up at 4 different locations at once, spread across a huge stretch of open ocean, is a completely different kind of evidence entirely. It strongly suggests something is happening to the entire system as a whole, not just one small corner of it. Picture a treadmill that's supposed to run at a fixed, steady speed no matter what, hour after hour. Now, picture someone gradually turning the dial down, so slowly you might not notice from one single day to the next. But after 20 years of checking the readout regularly, the slowdown becomes completely impossible to miss or explain away as a fluke. That's essentially what these 4 ocean monitoring stations recorded happening to one of the most important currents on the entire planet. A separate scientist not involved in the Miami study, René van Westen from Utrecht University, reviewed these findings independently and called them strong observational evidence that the conveyor is indeed declining right now, in the present moment, not just inside some future climate model on a screen. He didn't stop there either. He pointed out clearly that this measured weakening means the risk of the current eventually reaching a genuine tipping point, a point of no return it can't come back from, is becoming more substantial with every single year the slowdown continues unchecked. So the conveyor belt is now confirmed to be slowing down, measured directly across 2 solid decades of real data. The obvious next question is why? What's actually breaking a system that has run reliably for thousands of years without failing once? The answer connects directly back to something you've probably already watched happen on the news without ever realizing it was quietly sabotaging an ocean current thousands of miles away the whole time. Remember how the Atlantic conveyor actually works, since it genuinely matters here. Warm water flows north, releases its heat into the air above it, then becomes salty and dense enough to sink, which is the entire engine that keeps the whole loop running continuously without ever stopping. That sinking step is not optional in any way. It's the single most important part of the entire system, the part everything else depends on. Without dense water sinking in the north, the conveyor belt has no reason to keep pulling more warm water up from the tropics behind it, and the whole loop starts to stall. Here's the problem scientists are watching unfold in real time. Salt is what makes that sinking process work in the first place, because saltier water is naturally denser and heavier than fresh water, even when both are sitting at the exact same temperature. And right now, enormous amounts of fresh water are pouring into exactly the spot where this sinking needs to happen, because glaciers and ice sheets across the Arctic, especially across Greenland, are melting at a genuinely rapid pace due to a warming planet. Picture pouring a full glass of fresh water directly into a swimming pool full of salt water. Right where you pour it, the water becomes noticeably less salty and less dense than the water sitting all around it. Now imagine that happening continuously, year after year, decade after decade, across a massive stretch of the Arctic Ocean, exactly where the conveyor belt depends on dense water sinking to keep the entire loop moving forward. That's essentially what melting glaciers are doing to the conveyor's engine room right now, diluting the exact water that the whole system needs to stay heavy enough to sink properly. Researchers have traveled all the way to Disco Bay in Greenland, specifically to study this firsthand, watching enormous chunks of ice the size of entire city blocks carve off directly into the water that eventually feeds into this critical northern sinking zone. Scientists directly link this ice melt to the disruption they're now measuring in the conveyor's salt balance. And this connection is treated as well-established fact within climate science today, not a shaky guess pieced together after the fact. So the ice melting up north isn't some separate, unrelated story happening far away from the ocean conveyor belt slowdown, disconnected from it. It's one of the primary mechanisms actually driving the slowdown itself, feeding directly into it every single day. The same way a spark and a puddle of gasoline aren't two separate stories. They're one single connected event, just waiting to happen. And once fresh water dilutes that critical sinking zone enough, the entire conveyor belt loses some of its natural driving force. The same way a car engine sputters and stalls when its fuel gets contaminated with something it was never built to run on. But this isn't just a brand new discovery invented from scratch by today's scientists working alone. There's a decades-old climate mystery sitting right in the middle of the North Atlantic Ocean that researchers puzzled over for a full 100 years. And it turns out that mystery had been quietly pointing straight at this exact slowdown the entire time, just waiting patiently for someone to finally connect the dots. For roughly 100 years, scientists tracking ocean temperatures carefully noticed something odd sitting in the middle of the North Atlantic, south of Greenland, in open water most people will never sail across in their entire lives, let alone visit at all. While most of the planet's oceans were gradually warming due to climate change, one specific patch of ocean stubbornly refused to follow along with everywhere else around it. It stayed unusually cold, year after year, decade after decade, standing out clearly on every temperature map against the warming trend happening everywhere around it. For a long time, this cold patch was treated almost as a curiosity, a strange local exception that simply didn't fit the bigger picture scientists were building year after year. Scientists nicknamed it, informally, something like the Atlantic's chilling secret, because nobody could fully explain why it was behaving so differently from every other patch of ocean on the entire planet, in every direction around it. Then researchers finally connected this century-old mystery directly to the slowdown itself, and suddenly the strange cold spot made complete, obvious sense to everyone carefully studying it. Remember, the whole conveyor belt system works by carrying warm water north from the tropics, all the way up toward the cold waters of the Arctic. If that conveyor is weakening, less warm water is reaching this particular region than used to arrive there in the past, decade after decade. Less warm water arriving naturally means the water sitting there stays colder than it otherwise would, even while the rest of the planet's oceans continue heating up steadily all around it. This cold spot isn't some unrelated coincidence sitting off on its own, disconnected from everything else happening around it. It's essentially a giant, visible fingerprint left behind by a weakening conveyor belt, hiding in plain sight for a full century before scientists finally had the tools and the data connections needed to read it correctly and know what it meant. Researchers built climate models specifically to test this exact explanation, and only the models that included a weakened conveyor actually matched what's been observed happening at that cold patch in real life. Every other explanation researchers tried instead failed completely to reproduce the pattern showing up in the data, no matter how the models were adjusted. That's what genuinely strong scientific evidence looks like, when only one single explanation successfully accounts for something real that's actually been observed and carefully measured over time. Picture a detective story where investigators spend 100 years puzzling over one strange, stubborn clue sitting alone at a crime scene, and it only finally makes sense once they understand the full story unfolding around it. That's essentially what happened here, except the crime scene is the entire North Atlantic Ocean, and the culprit turns out to be a slowing conveyor belt that's been quietly losing power for decades, possibly even longer than anyone first suspected. Now that we understand exactly why the conveyor is slowing, and we can literally see the cold water fingerprint it has been leaving behind for 100 years, there's one enormous question left standing in front of everyone paying attention. What actually happens if this slowdown eventually crosses a line, and the conveyor belt doesn't just weaken further, but genuinely stops altogether. Here's a twist that surprises almost everyone the very first time they hear it explained clearly and carefully. Climate change is generally described as making the planet warmer overall, and that's absolutely true on a global scale. No argument there at all. But if the Atlantic conveyor belt weakens dramatically enough, or stops entirely, one of the most direct results wouldn't actually be warming in Europe. It would be the exact opposite outcome instead, ice cold instead of warm. Remember what this current actually does for an entire continent full of people. It carries enormous amounts of warmth from the tropics all the way up toward northern Europe, and that transported warmth is a massive part of why countries like the United Kingdom stay relatively mild despite sitting at a latitude that would otherwise deliver brutally cold winters, similar to parts of Canada found at that exact same distance from the equator. Take away that steady flow of tropical warmth, and you take away one of the main things currently protecting northern Europe from far harsher winter conditions than anyone living there today has ever personally experienced. Scientists studying this potential outcome describe genuinely serious consequences waiting on the other side of that shift. A weakened or stopped conveyor could push Europe into what researchers have directly called a winter deep freeze, a dramatic shift toward extreme cold that would upend agriculture, energy demand, and daily life across an entire continent that has built its infrastructure and expectations around a much milder climate for centuries, generation after generation. And the disruption wouldn't stop there either, because a system this massive touches far more than just European winters alone, reaching into places most people would never expect. The same slowdown is expected to accelerate sea level rise, specifically along the east coast of the United States, adding extra flooding risk to cities that are already dealing with rising water lapping at their streets. Beyond that, it's connected to a serious risk of prolonged droughts spreading across a wide swath of Africa, a region already facing significant water challenges of its own, year after year. Picture one single machine quietly running underneath the ocean out of sight, somehow connected by invisible threads to winter temperatures in London, flood risk in Miami, and drought conditions across an entire continent thousands of miles away from all of it. That's genuinely how interconnected this one ocean current actually is, with global weather patterns everyone already depends on without realizing it. This isn't a wild guess pulled out of thin air either, and it isn't built on a single shaky data point. It's grounded directly in what scientists have already confirmed happening: 20 years of measured slowdown, a century-old cold patch finally explained, and a clear physical mechanism involving melting ice, diluting the exact water this whole system depends on to keep functioning properly. The pieces all fit together into one consistent, evidence-backed picture that keeps holding up under closer scrutiny. So the natural next question becomes obvious, and it's the exact question researchers have been racing to answer with increasing urgency lately. If this slowdown keeps going, is there an actual point of no return waiting somewhere ahead? And if there is, how close might we already be standing to it right now? When scientists study something as complicated as an ocean current, the size of an entire ocean basin, they rarely agree on exact dates for anything at all, and this particular topic is genuinely no exception to that general rule. But in this specific case, some researchers have gone further than usual and actually put real numbers on the table, numbers specific enough to make headlines around the entire world overnight. A team led by Peter Ditlevsen, a climate researcher at the University of Copenhagen, published research predicting, with high confidence according to their own careful analysis, that the Atlantic conveyor could tip toward full collapse sometime between the years 2025 and 2095, a genuinely alarming range to see in print. That's a wide range of time, spanning a full 70 years, and Ditlevsen himself was careful and honest about the uncertainty built into that number from the very start. But he was equally clear about how seriously he personally takes the underlying threat behind it. In his own words, speaking directly about the finding to a reporter, He said he thinks people should be very worried, calling it a very, very large change, and pointing out plainly that this current has not fully shut off in 12,000 years, not once in all that time. Not everyone in the scientific community agrees with exactly how soon this could actually happen, and that kind of honest, ongoing disagreement between serious, credentialed researchers is a completely normal and healthy part of how real science genuinely works day to day, not a sign that something is wrong with the research itself or the people behind it. A separate, more recent study went even further in a different direction, calculating that the current is already on track to slow by more than half its current strength by the end of this century, a substantial weakening that turned out to be significantly stronger than what the average of all major climate models had originally been predicting for this same stretch of time. Picture standing at the edge of a tall hill, watching a boulder slowly rolling toward the steep part of the slope below you. Right now, researchers can't tell you the exact moment that boulder crosses over the edge and starts rolling on its own, completely unstoppably, but they can tell you, with real confidence, that it's already moving steadily in that direction, and that every year it keeps rolling forward, the edge gets a little bit closer. This isn't fear-mongering dressed up to look like science, and it isn't a scientist chasing headlines either. It's honest uncertainty layered directly on top of solid, measured evidence, exactly the kind of nuanced picture that real, careful research always produces when it's dealing with something this genuinely complicated and this hard to pin down precisely. And here's what makes this entire storyline even more unsettling than pure prediction and modeling on a screen. This isn't the first time in Earth's history that this exact current has slowed down dramatically or shut off entirely without warning. It's happened before, deep in Earth's past. And when scientists went looking for evidence of exactly what happened last time, what they found was almost impossible to believe, given exactly how fast the whole thing unfolded. Roughly 12,000 years ago, as the last ice age was finally ending and Earth's climate was steadily warming, something extraordinary happened to the Atlantic conveyor belt, something that changed an entire continent almost overnight. A massive glacial lake, holding an enormous amount of fresh water behind it, suddenly broke through whatever natural barrier had been containing it for centuries, and released that fresh water directly into the North Atlantic Ocean all at once, in a single catastrophic burst. Remember exactly what this current depends on to keep running smoothly. Salty, dense water needs to sink in the north to keep the whole conveyor loop moving continuously without stalling. That sudden, massive flood of fresh water diluted the salt content in the exact spot where sinking needed to happen, and it did so far faster and more dramatically than the gradual glacier melting happening slowly today. The conveyor belt's engine essentially stalled out completely, almost like flipping a switch, and the result wasn't subtle or gradual in any way. Europe, which had already been warming steadily as the ice age ended, plunged directly back into an extreme cold spell that lasted for almost an entire millennium, a full 1,000 years of brutal winter conditions, returning right in the middle of a warming world that had briefly thought it was safe. Scientists studying ice cores and ancient sediment layers have confirmed this event clearly and repeatedly, and it stands today as the most dramatic, well-documented example we have of exactly what happens when this specific current shuts down completely. This is confirmed history, not speculation, preserved directly in physical evidence dug up out of ancient ice and ocean mud that has waited patiently for thousands of years. Picture flipping a light switch, expecting the room to slowly and gradually brighten over several minutes the way a sunrise would. Instead, the room goes instantly, completely dark, and stays that way for what feels like forever. That's roughly the kind of abrupt shift Europe experienced 12,000 years ago, when this same ocean current shut down without warning, a jarring reversal that happened far faster than anyone living through it could have possibly predicted or prepared for in advance. Today's situation involves a slower, more gradual source of fresh water, glaciers melting steadily over decades, rather than one single catastrophic lake bursting open all at once like before. But the underlying mechanism triggering the shutdown is fundamentally the exact same one scientists are watching unfold right now. Fresh water diluting the exact spot where salty water needs to sink to keep the entire conveyor belt running. Researchers studying today's slowdown keep this ancient precedent firmly in mind at all times, because it proves conclusively that this system is genuinely capable of shutting down entirely, and that when it happens, the change doesn't necessarily creep in slowly and gently over centuries the way most people assume. It can arrive suddenly instead and reshape an entire continent's climate for generations to come. So, while the ocean's own internal engine shows real, measured signs of losing power down below the surface, something else has been happening at exactly the same time, but up above, in the sky itself, where an entirely different kind of unusual activity has been catching the close attention of scientists watching a completely different part of our planet's system. While researchers were busy tracking Earth's spin and its ocean currents down below, an entirely different group of scientists was watching something happening far above the surface, in the sky itself, and what they found was equally strange, just in a completely different, unexpected direction entirely, one that pointed straight up instead of down. In the early months of 2026, Earth experienced an unusual, well-documented surge of large, extremely bright meteors, the kind so intense they're officially called fireballs, streaking through the sky in broad daylight, visible even under bright sunshine, which is genuinely rare for anyone on the ground to witness firsthand. The American Meteor Society, an organization that carefully tracks these events across the globe using a real network of trained observers and cameras, documented a wave of major fireball sightings stretching from California all the way to Germany, spanning an enormous portion of the entire planet during just the first 3 months of the year alone. This is confirmed, documented activity, tracked by professional astronomers using real monitoring networks and real instruments pointed at the sky every single night of the year, not scattered rumors or unverified posts floating around social media. Earth passes through space debris constantly, every single day of the year, and normally this happens in fairly predictable patterns that scientists already understand well, patterns they can usually see coming weeks in advance. Most meteors people see on a clear night are tiny pieces of rock and dust, usually no bigger than a grain of sand, burning up completely harmlessly high in the atmosphere above us, gone in an instant. But a fireball is different, a much larger chunk of space rock, sometimes the size of a basketball or even bigger than that, producing a dramatically brighter, longer-lasting streak of light as it burns through the atmosphere at incredible speed overhead. Picture a normal meteor as a tiny spark jumping off a campfire, quick and easy to miss entirely if you happen to blink at the wrong moment. A fireball is closer to an entire log suddenly bursting into a visible shower of flame, and it holds everyone's attention outside for several full seconds at a time. This particular wave of fireballs stood out immediately to observers watching the sky that season, not just for how bright individual events were, but specifically because of how many happened, clustered together in such a short window of time, all across such a wide stretch of the globe simultaneously and without any obvious pattern connecting them. Scientists monitoring these events began asking an obvious question almost immediately, once the pattern became clear. Was Earth simply passing through the normal debris trail of some already known comet, the exact same explanation behind predictable, well-understood annual meteor showers like the famous Perseids every single summer? Or was something else going on entirely, something less familiar and considerably harder to explain using the usual playbook astronomers normally rely on for these kinds of questions? To answer that question properly, scientists needed to look closely at one single, especially dramatic event from this same surge. An event violent enough that it didn't just light up the sky harmlessly overhead for everyone to watch. It actually reached all the way down and crashed directly into someone's actual house. On a Saturday afternoon in March of 2026, A piece of the solar system came crashing straight down toward a home in North Houston, Texas. On a day that started out like any other, this wasn't a small, harmless streak fading quietly somewhere in the night sky. This was a genuine, 1 full-ton space rock, roughly the weight of a small family car, plunging directly through Earth's atmosphere in broad daylight for everyone below to see. As it tore through the air at incredible speed, the massive friction and pressure caused it to break apart violently, nearly 30 miles above the city, unleashing a shockwave so powerful it has been compared to detonating 26 tons of TNT explosive all at once, in a single instant that shook the ground below. People across the region heard and felt the boom rattle their windows without having any idea what had actually just happened above their heads a moment earlier, high up in the atmosphere. Video captured by a National Weather Service meteorologist in Pittsburgh even caught the entire moment from a distance, confirming the event clearly on camera for anyone who doubted it happened at all, no matter how unbelievable it sounded to hear. But the story didn't end there with just a boom in the sky. One dark, jagged fragment of that shattered space rock survived the fiery descent all the way down, and it smashed directly through the roof of an actual home below. Witnesses described it ricocheting around inside a bedroom, almost like a small, violent game of cosmic pinball, tearing through drywall and furniture in a house where someone had been living an entirely ordinary day just moments before it all happened. Picture standing in your own bedroom, one you know as well as any place on Earth, familiar down to every poster on the wall, and having a piece of actual space suddenly punch straight through your ceiling and bounce off your walls without any warning at all. That's not a scene pulled from a movie script. It genuinely happened to a real family, in a real house, and it's fully documented by news coverage and eyewitness accounts from that day. And here's the part that turns this from one wild, unlucky story into a genuine scientific pattern worth investigating much further, one that stretched across an entire season. This Houston event wasn't some isolated, freak occurrence happening entirely on its own, out of nowhere. It happened right in the middle of that same broader fireball surge. Scientists were already tracking across an enormous stretch of the globe during those very same months. One dramatic, house-shaking event doesn't automatically prove some larger, undiscovered trend all by itself, not on its own, no matter how dramatic it looked on the news. But when researchers stepped back and studied the wider patterns surrounding it more carefully, they noticed something that made this surge look considerably less random than a normal, ordinary cluster of coincidental space debris simply passing by on schedule. The rocks streaming toward Earth during this specific period were traveling on an unusual path through space, one that pointed towards something other than the typical, well-understood explanation astronomers usually reach for first when a meteor shower shows up right on time. Everything up to this point has happened above you or below the ocean, far from anywhere you could actually stand on solid ground. This next part is different. This part happens right under your feet, on solid ground, in places people live every single day. It is called a sinkhole, and the name describes exactly what happens. The ground simply sinks, sometimes gently over months, sometimes in an instant, swallowing whatever sits on top of it. In one recent case, a sinkhole opened in Omaha, Nebraska, an ordinary American city with no volcanoes, no fault lines, nothing exotic about its geology at all, just a regular street, and then suddenly not a regular street anymore. This is not rare or isolated in any sense. Around the world, in the same recent stretch of months, sinkholes and sudden ground collapses have been documented across multiple countries, sometimes swallowing streets, sometimes threatening homes, sometimes appearing in places with zero warning signs beforehand whatsoever. This is confirmed, photographed, documented reality, not rumor. The United States Geological Survey, the government agency responsible for studying America's land and water, states plainly that sinkholes happen when the ground below the surface can no longer support the ground above it. Picture a strong wooden floor sitting on top of weak, rotting beams you cannot see. From the top, the floor looks completely fine. You could stand on it for years without noticing anything wrong. But underneath, the support is quietly failing, piece by piece, until one day the floor simply is not there anymore. That is essentially what is happening beneath entire neighborhoods in certain parts of the world, except instead of wooden beams, the hidden support is rock, and instead of years, some of these collapses happen in seconds flat. Sinkholes are not new. They have existed for as long as Earth has had rock and water sitting together underground. But scientists tracking this phenomenon note that certain sinkholes are increasingly tied to changing groundwater levels, which shift as weather patterns change and water usage increases in growing cities around the world. Some regions are seeing sinkhole activity spike specifically during droughts, when farmers and cities pump extra groundwater from underground to make up for the lack of rain, unintentionally removing the very support that was holding weak rock formations together from below. In one well-documented case in Florida, more than 100 sinkholes opened in a single farming region during a single freeze event, after farmers pumped enormous amounts of groundwater overnight to protect their crops from the sudden cold. The sinkholes destroyed homes, roads, and farmland within days, leaving entire families without a place to live. This connects directly back to everything you have already learned about melting ice and shifting water patterns across the planet. Water that used to sit predictably in one place, whether frozen at the poles or steady underground, is now moving in ways it never used to. And the ground itself is responding to that shift in real time. To understand exactly why solid rock can simply give way beneath a house or a road with almost no warning at all, you need to understand what is actually happening to that rock, deep underground, completely invisible from the surface, for years before anyone ever notices a single crack. Most people simply assume rock is permanent, solid, unchanging, the one thing you can always count on to stay exactly where it is, decade after decade. For most rock, everywhere, that is true. But certain types of rock, especially limestone, are not nearly as permanent as they look. And the reason comes down to something as ordinary as rainwater. As rain falls through the sky, it absorbs a small amount of carbon dioxide from the air, the same invisible gas you breathe out with every single exhale you take. That reaction creates a mild acid, similar to the fizzy acid inside a can of soda, though far weaker than that. On its own, that acid would never bother you at all. It cannot burn your skin or hurt you in any way whatsoever, no matter how much of it touches you. But given enough time, that same mild acid can slowly dissolve limestone, the same way sugar slowly dissolves in a glass of warm water if you stir it long enough without stopping. The difference between the two is speed. Sugar dissolves in seconds. Limestone takes centuries to fully break down. As rainwater and groundwater seep down through cracks in limestone bedrock, they slowly eat away at the rock from the inside out, widening tiny fractures into larger channels and larger channels into genuine underground caves, completely invisible from the surface above ground. This process is called karst, and geologists have studied it carefully for well over a century now, all around the world. It is confirmed, well understood science, not a mystery in any way. Picture a block of cheese sitting in a warm room for years. From the outside, it looks completely solid, but slowly, invisibly, it is developing pockets and holes on the inside that you would never guess were there just by looking at the surface from above. Limestone under the ground behaves the same way, except the timescale is centuries instead of days, and the pockets can grow large enough to swallow an entire house whole. Roughly 40% of the United States sits above rock types that can dissolve this exact way, according to government geological surveys, meaning a huge portion of the country is quietly sitting above a slowly developing network of underground caves that most residents will never even know exists beneath their feet. Right now, today. For a long time, these hidden caves stayed stable, because groundwater filling the caves provided support, almost like water inside a balloon, holding its shape from the inside out, evenly and predictably. The water pressure pushed back against the rock above, keeping everything in careful balance for years at a time. But when groundwater levels drop, whether from drought, heavy pumping, or changing rainfall patterns tied to a warming planet, that invisible support disappears entirely. And once the water that was quietly holding a cave's ceiling in place is gone, gravity takes over completely, and it does not wait patiently for anyone. Sometimes a cave holds for decades after the water disappears. Sometimes it gives way in seconds flat. Understanding exactly what tips a slowly hollowing patch of ground from stable to catastrophic collapse required scientists to look closely at cases where the ground gave way suddenly, without warning, directly beneath people's homes and streets. Not every single sinkhole behaves the same way, and the difference between the two main types matters more than most people realize. Some form gradually, a slow, gentle dip in the ground that grows a little deeper every year, easy to notice and usually easy to avoid entirely. Geologists call these cover subsidence sinkholes, and they rarely surprise anyone who lives nearby, since the change is so gradual and easy to spot early. But there is a second, far more dangerous type, called a cover collapse sinkhole, and this is the type that makes headlines, because it can turn a normal street into a crater in a matter of seconds, with almost no warning beforehand at all. Here is exactly how it happens, step by careful step, all underground. As rainwater slowly dissolves limestone underground, it creates an empty cave hidden beneath a layer of soil and sediment that sits closer to the surface above it. For a while, that soil layer manages to hold its own shape and weight, forming what geologists describe almost like a bridge or an arch, strong enough to support itself and whatever sits directly on top of it. A road, a house, a parking lot full of cars. Picture an old stone bridge with its support pillars slowly crumbling away underneath, one at a time, while the bridge itself still looks perfectly solid from above the water. For a while, the bridge holds, because the remaining structure is just barely strong enough to keep standing. But there comes a point where one final piece gives way, and the entire bridge collapses suddenly and completely, all at once, in a single moment, instead of gradually the way it had been failing before. That is essentially the physics behind a cover collapse sinkhole. The underground cave keeps growing larger, month after month, year after year, while the thin layer of soil above it keeps thinning and weakening, completely invisible to anyone walking or driving on top of it every day. Then, one day, often triggered by something as simple as heavy rainfall adding extra weight, or a nearby construction project adding extra pressure, the soil arch finally fails, and everything above it drops straight down into the cave below, all at once and without any warning. This is confirmed geological mechanism, documented and studied extensively by government geological surveys around the world for many decades now, not speculation of any kind. There are sometimes small warning signs beforehand for anyone paying close attention: a slight new dip in the ground, water pooling somewhere it never used to, a fence post or tree that has started leaning at a strange, unnatural angle. But these signs are often too subtle for anyone to notice until it is already far too late to act. This is precisely why sinkholes feel so unsettling to the people who experience them firsthand. The ground had seemed completely solid for years, sometimes decades, right up until the exact moment it wasn't anymore. And this same basic principle, something invisible and heavy pressing down for a very long time, only to be suddenly released all at once, does not just apply to soil sitting above a hollow cave underground. It applies to something far larger and far more explosive, sitting underneath some of the most dangerous mountains on the entire planet. Iceland sits in one of the strangest spots on the entire planet, perched directly above the boundary where two massive tectonic plates are slowly pulling apart from each other, with a river of superheated rock flowing just beneath the surface at all times. This makes Iceland one of the most volcanically active places on Earth, and it also happens to be covered in glaciers, an unusual combination that most countries never have to deal with at the same time. Around 15,000 years ago, during the peak of the last ice age, Iceland was buried under an enormous sheet of ice, far thicker than anything covering the island today. Then the ice age ended, and over the course of just a few thousand years, most of that thick ice cover disappeared entirely, melting away as the whole planet warmed. Scientists studying this exact period found something remarkable. As the ice disappeared, something happened underneath it that nobody expected at first. Volcanic eruption rates across Iceland did not just increase slightly, they increased by an estimated 30 to 50 times their normal rate. An explosion of volcanic activity that lasted for roughly 1,500 years before finally settling back down to more typical levels. This is confirmed by researchers at the Icelandic Meteorological Office, the official government agency responsible for monitoring volcanic activity across the entire country, day and night, year-round. Michelle Parks, a scientist who coordinates volcano monitoring there, has studied this connection closely, and the mechanism behind it is actually simple once you picture it correctly. Think about a heavy stack of books sitting on top of a spring for years. The weight of the books presses the spring down, keeping it compressed and still. Remove the books suddenly, and the spring does not just relax gently back into place. It springs upward with real force, releasing all of that stored energy at once. A massive glacier sitting on top of a volcano works in a strangely similar way. The weight of thousands of feet of solid ice presses down on the magma chamber underneath, actually helping to keep it contained and suppressed, the way a heavy lid holds down a boiling pot of water. When that ice suddenly disappears, the pressure holding the magma in check disappears along with it, and the volcano becomes far more likely to erupt, and to erupt more violently than it would have with the ice cover still in place. Iceland's remaining glaciers today cover only around 10% of the land they once did during the peak of the Ice Age, and they continue shrinking rapidly as the modern planet keeps warming decade after decade. Scientists at the Icelandic Meteorological Office are now watching closely to see whether this exact same pattern, ice retreating and volcanic activity rising in response, might be starting to repeat itself in real time, driven this time by human-caused climate change instead of the natural end of an ice age thousands of years ago. If a connection this dramatic and this well-documented already happened once in Iceland's own history, an obvious and unsettling question follows immediately. Could the exact same mechanism be quietly setting up somewhere else on the planet right now? Somewhere far larger, far colder, and far less watched than one volcanic island in the North Atlantic Ocean. To understand exactly how much pressure a melting glacier can release from a volcano underneath it, scientists needed a real, physical example they could study in careful, exhaustive detail, not just a general theoretical idea sketched out on paper. They found one in southern Chile, at a volcano called Mocho Chochuenco, a now dormant mountain sitting quietly in the Chilean Andes mountain range. Researchers from the University of Wisconsin-Madison studied Mocho Chochuenco alongside 5 other nearby volcanoes, scattered across the same mountain range, using a technique called argon dating, which allows scientists to measure the exact age of volcanic rock samples with remarkable precision, sometimes down to individual centuries of accuracy in their readings. What they found painted a strikingly clear picture of exactly what happened as the last ice age slowly came to an end across the entire region. Around the peak of the ice age, roughly 20,000 years ago, a massive ice sheet blanketed this entire region of Chile completely, pressing down on the volcano below with tremendous, sustained weight for thousands of years without pause or interruption. Underneath that ice, a huge reservoir of molten magma slowly accumulated over thousands of years, sitting between 6 and 9 miles beneath the surface of the ground, held in check and firmly suppressed by the sheer weight of the ice, pressing down from above without pause. Then, as the ice age ended, the ice sheet retreated rapidly across the whole region, and the crust beneath it responded almost immediately to the sudden change in weight. With the ice gone, the ground itself physically relaxed and expanded slightly upward, and trapped gases inside the magma below suddenly had far more room to expand outward as well. Pablo Moreno Jaeger, the researcher who led this study, compared the effect to shaking a bottle of soda and then popping the cap off all at once. All that built-up pressure, trapped for thousands of years, needed somewhere to go, and it found release in a series of explosive volcanic eruptions once the ice sheet's weight was finally gone. This is not speculation of any kind. It is measured directly from rock samples that recorded the exact timing of the eruptions as they happened, layer by careful layer, like rings inside a tree trunk telling its own story. The eruptions that followed were significantly larger and more explosive than typical eruptions from the same volcano before the ice ever melted away in the first place. Moreno Jaeger's research team emphasizes one especially important detail that makes this discovery matter far beyond just the borders of Chile itself. The specific combination required to trigger this kind of eruption surge is very thick glacial ice, sitting directly above an active magma chamber for a long, sustained period of time, without any major interruption. That is a very particular, specific combination of ingredients, and it does not exist in very many places around the entire world. But it does exist, in a big way, in one very specific location that most people never think about as a volcanic hotspot at all. A place so remote and so cold that almost nobody has ever set foot there, and where hundreds of similar magma chambers may currently be sitting under exactly the same kind of pressure right now. Ask most people to picture Antarctica, and they will likely describe an endless field of ice and snow, silent, frozen, and about as far from volcanic activity as anywhere on Earth could possibly be imagined by anyone. That picture is wrong, and scientists have known it is wrong for years now. Buried beneath Antarctica's thick ice sheets sits one of the largest concentrations of volcanoes found anywhere on the entire planet, far more than most scientists expected to find there originally. Researchers have identified at least 100 separate subglacial volcanoes across West Antarctica alone, mountains of buried volcanic rock that most people have never heard of in their entire lives, hidden completely from view under miles of solid ice that has sat undisturbed for thousands of years without moving. For a very long time, these volcanoes stayed quiet and dormant, suppressed by exactly the same mechanism scientists documented in Iceland and in Chile. The sheer physical weight of thick glacial ice pressing down on their magma chambers from above, keeping everything locked firmly and securely in place for millennia. But Antarctica's ice is now melting, and it is melting rapidly, especially across West Antarctica specifically, where warming ocean water is eating away at glaciers from below at a pace that has genuinely alarmed climate scientists studying the region closely for years. Researchers presenting new findings at the Goldschmidt Conference, a major international geochemistry conference held in Prague every year, directly connected the well-documented Iceland and Chile examples to what could realistically happen next in Antarctica, specifically, given enough time. Their conclusion was stated plainly: as Antarctica's glaciers continue steadily retreating due to climate change, the hundreds of volcanoes buried beneath that ice could become significantly more active over time, potentially erupting more frequently and far more explosively than they have at any point in recorded human history. This is confirmed as a genuine, credible scientific concern actively raised by real geochemists at a real international science conference, not a wild guess pulled from thin air by anyone involved. At the same time, it remains a prediction about a future possibility, not something that has already happened or been directly observed occurring in Antarctica itself just yet, right now. Scientists are careful and precise about that important distinction, and you should be too, when you hear headlines that compress nuance into a single scary sentence. Nobody is claiming Antarctic volcanoes are erupting today, right now, as you listen to this. What researchers are saying is that the exact physical conditions required to trigger this kind of eruption. Surge, thick ice, retreating rapidly from above active magma chambers, are currently developing in Antarctica in real time, the same way they once developed in Iceland thousands of years ago, and more recently in Chile as that region's own ice sheet retreated. And there is something else about a subglacial eruption that makes this story even stranger and even more worth watching closely as the coming years unfold. When a volcano erupts underneath a massive sheet of ice instead of open air, the consequences do not stay contained underground where they started. They can reach all the way up through the ice itself and out into the world above in ways that genuinely startle the scientists who study them for a living. By now, you have heard the same basic pattern repeat itself 3 separate times in 3 completely different places on the entire planet. Iceland, thousands of years ago. Chile, at the exact same time, on the opposite side of the globe. And now, potentially, Antarctica too, unfolding in the present day, right in front of scientists, watching closely. It is worth slowing down for a moment to understand exactly why removing ice specifically has this kind of dramatic effect on a volcano sitting underneath it, because the physics involved is simpler and more intuitive than it might initially sound to anyone hearing it for the first time. Picture holding a can of soda that has been shaken up hard, still fully sealed, with the cap screwed on tight. Nothing happens while the cap stays on. The pressure inside is trapped, held in check by the solid seal keeping it contained. But the instant you crack that seal open, even just slightly, everything trapped inside rushes outward all at once, fast and forceful. A glacier sitting on top of a volcano works as that exact same kind of physical seal, just built from ice instead of aluminum and plastic. The tremendous weight of thousands of feet of solid ice presses down steadily on the rock and magma underneath it, and that pressure actually helps keep gases dissolved and trapped safely inside the magma. The same way pressure inside a sealed can keeps carbon dioxide dissolved inside your soda instead of fizzing out. Remove that ice, and you remove the pressure holding everything in check underneath it. Gases that were compressed and trapped inside the magma suddenly have room to expand rapidly, and that expansion is exactly what drives an eruption to become more violent and more explosive than it otherwise would have been with the ice weight still fully in place. Scientists describe this general process using the term decompression, which simply means a sudden, significant drop in pressure acting on something that used to be under a great deal of compression before. It applies to volcanoes losing their ice cover, and interestingly, it applies to deep-sea divers as well, who must rise to the surface slowly and carefully to avoid a dangerous version of this exact same basic effect happening inside their own bodies as pressure drops around them. The connection between melting ice and increased volcanic activity is not some wild, disconnected coincidence, stitched together after the fact by desperate researchers. It is one single, consistent physical mechanism, decompression, showing up again and again in completely different corners of the planet, separated by thousands of miles and thousands of years, yet following the exact same basic rule of physics every single time it occurs. Ice melting away is reshaping Earth's oceans, Earth's spinning speed, and now, quite possibly, Earth's volcanoes as well. All through the same fundamental cause playing out in different forms across the world. But ice and water are not the only forces currently acting on this restless planet. High above Earth's atmosphere entirely, something else has been growing steadily more active and more intense. A force with the raw power to reach all the way down to the ground itself, in a way that has left even experienced scientists genuinely surprised by what they discovered. 93 million miles away, the sun runs on its own internal clock, cycling through roughly 11 years of calm, followed by roughly 11 years of intensifying activity. Over and over, in a rhythm scientists have tracked closely for centuries now. Right now, in 2026, the sun is sitting close to the peak of that cycle, a period astronomers officially call solar maximum, and this particular peak has been genuinely dramatic to watch unfold from here on Earth. During solar maximum, dark, Magnetically twisted patches called sunspots multiply rapidly across the sun's entire surface, and those same tangled magnetic fields regularly snap and release enormous bursts of energy called solar flares, along with massive clouds of charged particles called coronal mass ejections that go streaming out into space at incredible speed toward Earth. This current solar cycle, officially named Solar Cycle 25, has already produced some genuinely powerful events worth noting. In October of 2025, the Sun released an X9 flare, one of the most intense categories of solar flare that scientists actively track, powerful enough to disrupt high-frequency radio communication here on Earth almost instantly upon arrival at our planet. Then, in January of 2026, Earth experienced one of the most intense geomagnetic storms of this entire solar cycle so far, a direct result of charged particles from the Sun slamming into our planet's magnetic field and shaking it violently. This is confirmed, measured activity, tracked continuously by space agencies using dedicated satellites built specifically to watch the Sun around the clock every single day of the year. Picture the Sun as a campfire that flares up and calms down in a predictable, repeating rhythm over many years of steady burning. Most of the time, the flames stay low and steady, barely worth a second glance from anyone standing nearby. But during certain stretches, the fire roars up dramatically, throwing sparks in every direction at once. And that is essentially what solar maximum looks like happening on a star instead of in your own backyard. These solar storms genuinely matter to life on Earth in concrete, measurable ways. They can disrupt satellite operations, interfere with the satellite navigation systems that guide phones and airplanes, threaten power grids on the ground below, and in extreme cases, force airlines to reroute polar flights entirely to avoid radio blackouts caused by the incoming radiation. On the beautiful side of this same coin, strong geomagnetic storms also push the aurora, those glowing green and purple curtains of light, much farther from the poles than usual, letting people see them from places that almost never get a glimpse of that kind of sky. This particular solar maximum arrives at an unusually crowded moment for planet Earth, layered directly on top of a weakening magnetic shield, a slowing ocean current, and a spinning planet that cannot seem to settle on a steady rhythm of its own right now. And it turns out an especially active sun might be doing more than lighting up the sky and threatening satellites far above our heads. Some scientists have begun asking a genuinely bold question, one that sounds almost too strange to take seriously at first, until you actually hear the reasoning laid out carefully and see exactly how they built the case for it, piece by careful piece, one step at a time. In February of 2026, a team of researchers at Kyoto University in Japan published a study proposing something that sounds, at first listen, almost too strange to take seriously at all. Could solar flares, enormous bursts of energy erupting from the surface of the sun, actually help trigger earthquakes here on Earth, thousands of miles away from the sun itself? Before dismissing that question outright without a second thought, it is worth understanding exactly how the researchers carefully built their case, step by careful step, using real physics grounded in evidence. Earth's upper atmosphere contains a layer called the ionosphere, filled with electrically charged particles, sitting roughly 250 miles above the surface of the planet, far above where airplanes fly. The research team, led by an applied mathematician named Ken Umeno, modeled Earth's crust and this ionosphere layer as two ends of a single, enormous electrical system, similar in principle to a giant battery stretched across the whole planet from top to bottom. Deep inside Earth's crust, especially in fractured zones near fault lines, water exists under extremely high pressure and temperature, and that water can carry a small electrical charge of its own, quietly, without anyone noticing. When a solar flare hits Earth's atmosphere, it shifts electrons within the ionosphere, pushing them downward and creating a layer of negative charge sitting lower in the atmosphere than usual. According to the model, this shift can produce a small but measurable electric field reaching all the way down into the crust itself, thousands of miles below where the flare first struck, in a fault line that is already dangerously close to slipping, already under tremendous natural stress from tectonic pressure built up over years, or even decades of quiet buildup. This tiny additional electrical nudge might be just enough to push it over the edge and into motion. Umeno himself was careful and precise about exactly what the model does and does not claim to explain about the underlying physics. In his own words, he stated plainly that they are not claiming solar flares generate the actual tectonic stress driving an earthquake in the first place at all. Their argument is about timing, not energy, meaning the sun might influence exactly when an already unstable fault finally slips, not what originally built up the underlying pressure in the first place. Researchers pointed to Japan's 2024 Noto Peninsula earthquake, which happened to coincide closely with a period of intense solar activity, as one possible supporting example worth studying further in future research going forward. This is clearly and explicitly labeled a theory by the very scientists proposing it, not a confirmed scientific fact, and the distinction matters enormously here, more than almost anywhere else in this video. It is a genuinely interesting, carefully reasoned hypothesis built on real physics, submitted for other scientists to scrutinize, test, and potentially disprove through further careful research over time and repeated study. And in real science, that kind of open scrutiny from skeptical colleagues is not something researchers try to avoid or dodge out of fear. It is the entire point of publishing in the first place, and what happened next to this particular theory shows exactly why that process matters so much to how trustworthy science actually works in practice. Good science invites its own critics, and the solar flare earthquake theory received plenty of them almost immediately after it was first published to the wider world. Nicholas Schmer, a geophysicist at the University of Maryland, who was not involved in the original study at all, described the idea as highly speculative when reporters asked him about it directly and honestly. He argued that far more evidence would genuinely be needed before anyone could reasonably claim a real, proven connection exists between solar activity and earthquakes happening on the ground far below the surface. He went even further, suggesting that the handful of cases researchers point to as supporting evidence might simply be coincidences, nothing more than random overlap between two types of events that both happen fairly often on their own, completely independent of each other entirely. Viktor Novikov, a geophysicist at the Russian Academy of Sciences, raised a separate, more technical concern about the model itself and exactly how it was originally constructed by the team. He pointed out that the researchers' calculations may not fully account for how much electrical resistance exists within different layers of rock inside Earth's crust, resistance that could potentially weaken or completely block the tiny electric field described in the model before it ever reached a fault line deep underground. The United States Geological Survey, the official government agency responsible for monitoring earthquakes across the entire country, has stated clearly and repeatedly over the years that earthquakes do not follow the sun's 11-year solar cycle in any obvious, predictable, repeating pattern that scientists have ever been able to reliably detect. If solar activity genuinely triggered earthquakes in any significant way, you would generally expect to see more earthquakes clustering, specifically during solar maximum years compared to quieter years, and that clear pattern simply has not shown up clearly in over a century of careful earthquake records kept by seismologists worldwide. None of this means the Kyoto University researchers were wrong about their idea, and none of it means their idea is worthless or should be dismissed outright without any further consideration whatsoever. It means science is currently working exactly the way it is supposed to work when it functions properly and honestly. A team proposes a genuinely interesting new idea, builds a careful model to explain a possible physical mechanism, and publishes their reasoning openly for the entire scientific community to examine, test, and challenge from every possible angle available. Other experts, examining the same evidence from different backgrounds and different specialties, respond with real, substantive technical concerns, rather than simply believing or dismissing the claim outright based on gut reaction alone. This is precisely how legitimate science moves forward over time, through open disagreement between careful people, not through certainty or by force of confident authority. A theory this contested and this actively debated deserves to be labeled clearly as exactly that. A genuinely interesting theory, still very much being tested, not a settled, confirmed fact you should walk away believing without question or doubt. And this kind of honest labeling matters more here than almost anywhere else in this whole video, because it is a small, clear preview of something much bigger about how every single discovery you have heard so far actually fits together into one larger picture worth seeing clearly. Take a step back now and look at everything you have learned so far as one connected picture, instead of a list of separate, unrelated facts sitting side by side. Earth's rotation has been speeding up and then slowing down in ways scientists did not fully predict in advance, catching even experienced geophysicists off guard. A weak spot in Earth's magnetic shield has grown by half the size of an entire continent, while opposite sides of the planet's magnetic field mysteriously strengthen and weaken at the same time for reasons still not fully understood. A massive ocean current that keeps an entire hemisphere's climate stable has been measurably weakening for 2 full decades running, according to real sensors sitting in the ocean itself. The ground itself is opening up in cities that never used to worry about it at all. Volcanoes that stayed silent for thousands of years may be stirring awake beneath the ice in Antarctica right now, this very year. And the sun, currently near the peak of its own 11-year cycle, is possibly nudging fault lines that were already close to breaking on their own regardless. None of these events exist in complete isolation from each other, sealed off neatly in their own separate boxes with no connection between them. Nearly every single one connects back to the same root cause: ice melting away, water moving to places it never used to sit, and heat redistributing itself across a planet that is warming overall. Even while individual regions and individual seasons can still occasionally feel colder than expected in any given year or month, picture a single, enormous spider web, stretched taut across an entire garden from corner to corner. Touch just one single strand of that web, even gently, and the vibration travels outward along every other connected strand at once, reaching corners of the web that seem, at first glance, to have nothing at all to do with the spot where you touched it originally. Earth's climate system behaves in a strikingly similar way to that web. Melting ice at the poles does not just raise sea levels somewhere far away and stop there quietly. It measurably changes how fast the entire planet spins on its axis, day after day. It dilutes the salty water that an entire ocean current depends on to keep flowing steadily north. It removes the physical weight holding dangerous volcanoes in check beneath the ice far to the south. Every strand in this vast web is connected to every other strand, whether or not the connection is obvious or visible from where you happen to be standing at any given moment in time. This does not mean every single strange event happening on Earth right now traces back to exactly one single cause with no exceptions ever occurring. Some of what you have heard, like the solar flare earthquake connection, remains genuinely uncertain and openly contested among credentialed experts in the field. But the broader pattern connecting ice, oceans, rotation, and ground stability is measured, confirmed, and increasingly well understood by scientists working across many different specialties worldwide. And once you can see the whole web clearly, laid out all at once instead of one strand at a time, an important, calming question naturally comes next in your mind. Does all of this actually mean the world, as you know it, is somehow ending soon? Here is something worth saying clearly and directly right now, without any hedging or vague, cinematic language wrapped around it to soften the point unnecessarily. Not one single scientist named anywhere in this entire video, not Chris Finlay studying the magnetic field, not Shane Ellepot studying the ocean conveyor, not Pablo Moreno Yeager studying volcanoes, not Ken Omeno studying solar flares, has claimed that the world is ending. That sentence deserves to sit here plainly, on its own, without softening, because it is easy to hear a long list of genuinely dramatic, real scientific findings stacked back to back and quietly assume they must be building towards some final, catastrophic conclusion, waiting patiently at the end of the story for you. They are not building toward that conclusion at all. Every single researcher named in this video is doing something far more specific, far more useful, and honestly, far less dramatic than headlines about the end of the world tend to suggest. They are measuring one particular system extremely carefully, publishing exactly what they found in that specific system, and being remarkably honest and precise about the real boundaries of what remains genuinely uncertain in their own findings and conclusions overall. Chris Finlay explicitly stated his own study found no evidence at all of an approaching magnetic field reversal happening anytime soon on this planet. Researchers studying Antarctica's volcanoes were careful and precise to frame their findings as a future possibility worth watching closely over time, not something already happening today, right now, as you sit here listening. The scientists proposing the solar flare-earthquake connection openly welcomed serious, substantive criticism from other experts in their field, rather than trying to avoid or dismiss it defensively out of fear. This is what real, functioning science actually sounds like when you listen closely to the researchers themselves speaking directly, instead of only reading the most dramatic possible headline written specifically to attract clicks and attention online. Picture a team of careful engineers regularly inspecting a large, complicated old bridge, spanning many decades of continuous public use by thousands of people every single day. They notice a few new cracks that genuinely deserve close attention and further monitoring going forward, month after month, year after year, without fail. That is worth taking seriously, and it is worth continuing to watch closely over time, with real instruments and real expertise. It does not automatically mean the bridge is about to collapse tomorrow, or even sometime this year, or possibly ever, if the right monitoring and maintenance continues steadily. Earth is an old, complicated, constantly changing system, and it has weathered far bigger changes than anything described in this video. Many times before, across its long geological history, stretching back billions upon billions of years into the deep past. What makes this particular moment in history genuinely worth paying close attention to is not that anything happening right now is unprecedented or impossible to survive as a species. It is that, for the first time in the planet's entire multi-billion-year history, humans now have the precise scientific tools required to actually watch these changes unfold in careful, exacting detail as they are actually happening in real time, instead of only reconstructing them centuries or millennia later from old rock, ice, and mud. Every single system described in this video has real scientists actively watching it, right now, in this exact moment, using specific instruments built for exactly this purpose, and each one knows precisely what signal would tell them the situation has genuinely changed for better or worse going forward from here. This matters a great deal, because it means none of this is being left to guesswork or vague, uneasy feelings about the future ahead of us all. Take Earth's rotation first, since it started this entire story from the very beginning. Timekeeping officials are watching for whether the length of day keeps lengthening steadily through the rest of 2026, or whether it flips back towards speeding up again the way it did for years before this recent reversal. That single number will help determine whether the historic October vote to redesign the leap second system was truly necessary, or whether Earth quietly solves its own timing problem before anyone actually has to intervene at all. For the magnetic field, the Swarm satellite mission continues collecting fresh data every single day without pause or interruption, and researchers like Chris Finlay are specifically watching to see whether the reverse flux patches beneath the South Atlantic keep drifting the same direction, or whether they begin to shift course and slow down entirely on their own accord. For the ocean conveyor, the 4 monitoring stations off the coast of the United States keep recording continuously around the clock, day and night, and scientists are watching closely for any sign that the 20-year weakening trend is accelerating faster than existing climate models currently predict, which would be a serious warning sign worth taking real action on immediately and without delay. For Antarctica's volcanoes, researchers are watching satellite heat data and listening closely for unusual seismic activity underneath the ice, specifically the kind of signal that would suggest magma is genuinely on the move down there instead of sitting still and dormant as expected. And for the solar flare earthquake theory, other scientists around the world are now attempting to test Ken Umeno's model against historical earthquake records from other countries and other time periods entirely, checking carefully and rigorously whether the pattern holds up outside of the original Japanese dataset it was originally built from in the first place. Picture a hospital where every single patient is hooked up to their own dedicated monitor, each one tracking a different vital sign specific to that particular patient's own unique medical condition and history. No single monitor beeping on its own means the whole hospital is suddenly in crisis mode. It means one specific system is being watched closely, carefully, and professionally by someone who knows exactly what a dangerous reading would actually look like if one ever appeared on screen. That is precisely the situation with planet Earth right now. In this exact moment in time, multiple systems, each with dedicated experts watching closely, each with a clear, specific definition of what would count as a meaningfully concerning result worth acting on. None of them are reporting a crisis today. All of them are reporting genuinely interesting, carefully measured change, worth continued close attention over the months and years still ahead, as more data steadily comes in from research stations around the entire world. Here is a detail easy to miss in the middle of a video, covering this many different topics back to back, one after another, chapter after chapter. None of these individual events are actually new to Earth's long, layered history stretching back billions upon billions of years. Magnetic weak spots have come and gone many times across the planet's billions of years of continuous existence, long before humans ever walked the Earth. Ocean currents have slowed and sped back up before, tied to ice ages ending and beginning in cycles, stretching back much further than human civilization itself has ever existed on this planet. Volcanoes have erupted more explosively after losing their ice cover, over and over again, throughout Earth's deep geological past, long before anyone was ever around to notice or record it happening. The sun has cycled through calm and stormy periods for as long as it has existed as a star burning steadily in the sky above us, without a single true exception to that rhythm ever recorded. Sinkholes have opened in karst landscapes for as long as rain has fallen onto limestone anywhere on the planet's surface, quietly and repeatedly, decade after decade. What genuinely feels different about this particular moment in time right now is not any single one of these events happening in isolation from the others around it on its own. It is the fact that so many of them appear to be unfolding at roughly the same time within the exact same handful of years, layered directly on top of each other in a way that is unusually easy for scientists, working across completely different specialties, to notice and compare notes on together, almost for the very first time in history. A geomagnetism researcher studying satellite data does not typically read papers about ocean currents in their spare time between projects. A volcanologist studying Chilean rock samples does not typically follow earthquake research coming out of Japan either, in the normal course of their work. Yet all of these separate discoveries have been quietly stacking up in the scientific literature within roughly the same handful of years, close enough together in time that patterns connecting them are finally starting to become visible to anyone willing to actually look for them carefully across different fields of study and different countries. Picture an orchestra where every single musician has been quietly warming up and rehearsing alone in a separate room for years, each one completely unaware of what the others were practicing at the exact same time down the hall from them. Then, one day, they all happened to walk out onto the same stage together at exactly the same moment in time, and for the very first time, an audience can finally hear how all of those individual, separately rehearsed parts actually sound when they are combined and played together at once, in harmony. That is roughly what is happening in Earth science right now. In this very decade of human history, individual fields that developed separately for generations, magnetism, oceanography, volcanology, seismology, glaciology, are increasingly finding themselves describing pieces of the exact same, larger story unfolding right now, forcing researchers to talk across old boundaries between their different specialties more than they ever have before in the entire recorded history of modern science. Every single piece of evidence described in this video was measured using tools that did not exist even 50 short years ago, and most of it was measured using tools invented within just the last 15 to 20 years alone, well within living memory for most people alive today. The swarm satellites tracking the magnetic field launched in 2013, barely more than a decade ago from where we sit today. The ocean monitoring stations tracking the Atlantic conveyor have only been running continuously since 2004, not even a full generation back in time. High-precision atomic clocks capable of detecting a millisecond-level change in Earth's daily rotation only became widely available in recent decades, well after most adults alive today had already been born into the world. This is not a small detail buried quietly in the background of the story being told here today, easy to skip past without noticing. It fundamentally changes what it genuinely means to be alive on Earth during this particular decade in all of human history, compared to literally any decade that came before it, ever, at any point. For nearly the entire history of human civilization on this planet, spanning tens of thousands of years of human life on this planet, people experienced Earth's slow, gradual changes without any real way to measure them precisely as they happened in real time around them. A slight shift in ocean currents, a gradual weakening of Earth's magnetic shield, a subtle change in the planet's rotation speed, none of it was detectable to anyone alive at the time in history, no matter how carefully or closely they happened to be watching the world around them each and every day. Those changes simply happened silently in the background of everyday life, invisible and unmeasured, only becoming visible many centuries or millennia later to scientists piecing together fragments of evidence preserved carefully in old rock, ancient ice cores, and deep ocean sediment dug up slowly from the past. You are living through the first stretch of all human history where that is no longer true in the slightest sense whatsoever. Satellites orbit constantly overhead, sensors sit quietly on the ocean floor, recording every subtle change day and night without rest, and supercomputers process the resulting flood of information fast enough to reveal real, measurable patterns within months or years, not centuries or millennia, like before this modern era began. Picture standing at the edge of a river for the very first time in all of human history, with genuinely accurate tools to measure its exact flow, its precise temperature, and its true depth all at once, in real time, after countless previous generations could only ever stand at that exact same riverbank and guess at those same details, using nothing more than their own eyes and instincts to go on for guidance. That is the exact position you occupy right now, simply by being alive during this specific decade in Earth's very long and layered history. The systems described throughout this video have always been quietly changing underneath the surface, all throughout Earth's deep and distant past. What has genuinely changed for the first time ever in human history is that humanity now has a truly clear, detailed, real-time window into watching it all happen. Everything in this entire video traces back to one single planet, spinning through space at incredible speed, wrapped in an invisible magnetic shield, circled by vast moving oceans, covered in ice that is slowly disappearing year after year without pause, and dotted with volcanoes that remember far more about Earth's deep past than most people ever stop to consider in their own daily lives. None of these systems are separate from each other in any meaningful sense whatsoever, and none of them are separate from you either, sitting exactly where you are right now, listening closely to the very last part of this entire story. The rotation of the Earth beneath your feet quietly determines the length of the day you just lived through today, from morning to night, whether you ever notice that fact or not. The magnetic field wrapped invisibly around the entire planet protects the satellites that guide your phone every single day. You reach for it without thinking twice about how it actually works. The ocean conveyor belt sets the climate patterns that shape the food grown in the fields feeding your own dinner table this very week, whether you ever notice that connection or not while eating. The volcanoes stirring quietly beneath Antarctic ice will, one day, factor directly into a climate that your own grandchildren will eventually inherit from the world we all live in and share together today. This has never really been a video about some distant, disconnected planet floating far away out there in the vastness of empty space somewhere out there beyond our reach. It has always been a story about the one specific place every single person listening to this actually calls home. The only place any of us have ever truly known in our entire lives, from beginning to end. Scientists studying every single system described here today are not predicting a fixed, unavoidable ending written in stone somewhere far away from anyone's reach or understanding. They are documenting an ongoing, unfinished story that is still actively being written and revised, one careful measurement at a time, one honest published paper at a time, one openly debated theory at a time, year after year without stopping. Some chapters of that larger story remain genuinely uncertain still, openly contested between careful experts working in good faith with real evidence, sitting right there on the table for anyone to examine. Other chapters are as confirmed and solid as science manages to get on any subject anywhere in the entire world. Together, uncertain and confirmed, woven side by side into one larger whole, they form the most detailed, most carefully measured picture humanity has ever managed to assemble of the one planet we all quietly depend on every single day of our lives, without fail or exception. Keep watching the sky, the ocean, and the ground beneath your feet, because Earth is not finished changing, and neither is the remarkable story of the scientists patiently working around the world to understand it, one small, careful, honest discovery at a time, together, year after year, without ever stopping. If this kept you thinking until the very end of the story, there is more waiting for you, and this is far from the last story this planet still has left to tell you.